Okay.
Hi everyone, I'm Greg from Canva, and today I'm going to talk to you about Argo, Kubernetes native workflows and pipelines. A brief agenda for my talk today. I'm going to give a bit of background on Canva and what we do there. I'm going to recap on what I mean when I say workflow from a data engineering or machine learning perspective. Then on to the main topic of the talk, where I compare Argo and Airflow. Finally, if there's time, I'll do a very brief demo of Argo in action and maybe a bit of Q&A. If the time runs over, we can do this in the office hours that's been scheduled after this talk. So who or what is Canva? Canva is a Sydney-based startup, but we're made up of awesome people from all over the world. We're on a mission to empower the world to design. We build an app that allows you to create awesome designs. We have lots of templates and images and videos, so you can focus on creating your flyer or your birthday card or your t-shirt or your social media graphic, or even a presentation like this one. I created this presentation in Canva, and I'm not even a designer, so I think it looks pretty good. I brought a bunch of swag with me from Australia, so if you want some stickers or some freebies, come chat to me in the office hours. So how does Canva use workflows? We use workflows to improve the search relevance in our media library. We also use workflows to generate recommendations for our templates to our users. So sort of classic search and recommendation systems, as some of the speakers earlier today have spoken about. These use cases and others got us looking at the workflow tools available on the market and led us to Argo and Airflow. But what exactly is a workflow? The Oxford English Dictionary defines a workflow as the sequence of industrial, administrative, or other processes through which a piece of work passes from initiation to completion. Clear as mud, right? I prefer the Wikipedia description. A workflow consists of an orchestrated and repeatable pattern of activity. I really like that word, repeatable. I think repeatable processes are going to become more and more important in the data engineering and data science space. But what we really mean when we're talking about a workflow in data engineering or machine learning is a DAG, or directed acyclic graph. A DAG consists of a number of steps or tasks, and each task is a discrete amount of work. These tasks have dependencies on other tasks, and certain tasks can run in parallel, while some tasks are required to run in a predefined order. All these tasks together make up some larger piece of work or a workflow. Some examples you might have come across may be an ETL or an ELT job, a Spark job, machine learning jobs, CI jobs, deployment jobs, the list goes on. Workflows clearly cover a very broad range of use cases. So where do you start when picking a tool? There are so many different tools out there. Oozie, Luigi, NiFi, Azkaban. Arguably the most popular tool at the moment is Airflow. Can I see a show of hands of how many people in the audience are using Airflow? Oh, quite a lot. Anyone using Luigi? No. Oozie? Oozie, quite a lot of Oozie. Out of interest, anyone using AWS Data Pipeline? Oh, one. Oh, cool. I'll talk to you. So here's what an Airflow DAG looks like. You can see the dependencies between the tasks, and you can see how they make up a larger piece of work. Here's what a similar thing looks like in AWS Data Pipeline. AWS Data Pipeline was the first tool that we were using at Canva. I'll go a bit more into that in the next section of my talk. And finally, for comparison, here's what a DAG looks like in Argo. You can see that all these tools broadly have very similar, and they allow different pieces of work to be broken up into discrete tasks and allow you to define the dependencies between the tasks. So how did we come to compare Argo and Airflow at Canva? First, a story. We were a very small team at this point, where there were about 5 people who could be considered the data team at Canva. We were using AWS Data Pipeline, And it worked. It was actually pretty good for us. It was a complicated tool, but it's a complicated problem, and it's solved it reliably for us. But as time went on, cracks began to emerge, as they inevitably do. The team grew in scale and ambition, and we started running into limitations with AWS Data Pipeline. The frustrations and the grumbling started to happen more and more frequently. Some issues that we ran into were there were limitations in the types of the EC2 instances that you could run in the AWS Data Pipeline. Installing custom software is slow and awkward. We had to develop custom workarounds for the scheduling system. We ended up building our own cron triggers to activate the workflows. It's also a fairly niche tool. There's not much of a community or knowledge share around it. These issues and others got us looking into alternative workflow tools. Airflow was the obvious choice to consider, but we'd also come across another project called Argo that ticked a lot of boxes for us on paper. We didn't want to spend too much time evaluating all the tools on the market, so we decided to conduct a comprehensive proof of concept between Argo and Airflow to see which one would win for us. I'm sure everyone is already familiar with Airflow, but I'll just give a brief intro to Airflow. Airflow is the project that originated at Airbnb and is now an Apache project. You write your operators and your DAG in Python. It has a huge community. It's open source, so you can host it yourself, or if you're interested in commercial software as a service offerings, you can look at Cloud Composer from Google or Astronomer. Argo is a project that originated at Intuit through their acquisition of a company called Appletics. It is a Kubernetes native tool written in Golang. It is made up of a custom resource definition in Kubernetes and a custom controller that manages these custom resources. With Argo, the DAG is made up of containers, so it can be written in any language, not only Python. Can I get a show of hands from the audience on how many people are using Kubernetes in their work? Oh, wow. Cool. So for our proof of concept, we decided to implement a simple but realistic data pipeline that we already had. And we decided to re-implement it in Airflow and Argo to see what it would take to migrate to this tool. We set up both Airflow and Argo on AWS. We decided to set things up ourselves to get a better understanding of the various components and dependencies of both projects. We came up with a few evaluation criteria, and we got to work. Our main evaluation criteria was simple. It had to be suitable for the existing Canva workloads, which are mostly Apache Spark. It had to be easy to set up and operate. It needed a good workflow deployment story. It needed to have live logging and live UI updates. We also need timeouts and retries. And reproducibility is very important to us. We want things to be deterministic. A few things that we weren't looking for. We weren't looking for a visual UI for editing DAGs. We are all comfortable writing code in the team, and we prefer writing code to updating workflows in a UI. We aren't really looking for extremely dynamic DAGs. Our DAGs are mostly static, so basic conditional logic and loops are all that we really need. We don't have any use cases at the moment where we don't have a good idea of the inputs and outputs at the start of a workflow. And updating a DAG at runtime isn't something that we wanted. We consider a modification to a DAG to be a change, a new version of the DAG, and we expect it to be committed to Git. So what were the results of our evaluation? Both Airflow and Argo are very capable tools. We found that both could support Canva workloads. Both offer live UI updates and logging, and both have timeouts and retries. But there must have been some issues, right? The main issues we found with Airflow were the mutability and deployment of DAGs. The deployment of DAGs is clumsy, and you either have to poll Git or use rsync or some sort of shared file system to share the DAGs between the scheduler and the executors. There isn't an API to deploy your DAGs. This means that the DAG that is deployed is not necessarily the DAG that runs, because the DAGs on the scheduler and the DAGs on the executors are sort of eventually consistent. We also found the deployment of Airflow itself to be fairly complicated. There are a lot of moving parts, and while not all are necessary, depending on your scale, you almost certainly want to run the database and the scheduler on separate machines. You also have to monitor the web UI, the scheduler, and the executors. If you scale out using the Celery executor, it gets even more complex. We also noticed that there was a lot of excitement around the Kubernetes executor for Airflow. So we thought, why not just use Kubernetes directly instead? Of course, no tool is a silver bullet, and there are issues with Argo as well. One issue with Argo is the immense amount of YAML you have to deal with. Anybody using Kubernetes knows the management and templating of all this YAML gets very messy very quickly. Argo also requires Kubernetes. This is a high amount of complexity in itself and isn't for everyone. It has a lot of benefits, but it can be a chore to operate, even on some of the managed Kubernetes systems from AWS, Google, or Microsoft. So what was our decision? Ultimately, both tools are very capable. And the main thing that let Airflow down for us was its deployment of DAG story. We chose Argo because it has a better deployment story for the DAGs via an API and command line tool. We found that the DAGs were more declarative. We also like how the tasks are defined as containers. So if we do need to move to another tool in future, as long as the tool can run containers, it should be a relatively straightforward migration path. I'm now going to show a brief demo of Argo in action. I wasn't brave enough to do a live demo, so we've got it recorded. Oh, not that one. Okay, so this is going to be a basic demo showing what an Argo DAG looks like from the user perspective. So you can see in my folder here, I've got two YAML files, DAG workflow and DAG coin flip. I'm going to run the DAG workflow. This is what a DAG typically looks like. So at the top, you can see the custom Kubernetes resource definition of workflow. It's of kind workflow. And you can see that I'm going to generate a name called DAG workflow. The entry point for my DAG is start. And you can see that I've defined a template called start there that is a DAG. And inside the DAG is made up of tasks, remember? So we start with task A, and task A has no dependencies, so it's going to be the task that will start running immediately. You can have multiple entry points in Argo, so you don't only need to have one entry task, you can have numerous. You can see that the task A is going to run echo, which you'll see a bit later, and it's going to pass some parameters, message, and the value A. You can see task B as well. It has a list of dependencies, and it depends on A, and C likewise. C depends on A as well. And finally, task D, it depends on B and C. So you can imagine you've got task A, then two tasks B and C, and then D depends on B and C. So it'll form sort of like a diamond shape. Onto the actual, the business logic of the tasks. You remember at the beginning it was referencing a template echo. Echo is defined in the same YAML file, and you can see that echo is running Alpine Linux container. It can be your own container, it can be a Python container, and it's simply running, how do I get rid of this? It's simply running the echo command from bash in your shell, basically. But this could be a Python program doing model training or data preparation or hyperparameter tuning, anything really. And you can see that it's taking as a parameter input message that we were defining above. So task A was sending A, task B was sending B, task C was sending C. Now you're going to submit the DAG to Argo, running on your Kubernetes cluster. So there you go, you can watch it. So this is one mechanism of interacting with the DAG at runtime. You can visualize it running in your machine, so you can see that task A ran first at the top here, and B and C are pending. There you can see B and C running in parallel, and B and C are finished, and finally D. So there's a great little Argo CLI tool that lets you interact with the DAGs, and you can dive in with the CLI and look at the logs on each container. It's just a wrapper around kubectl, so you can also use the kubectl as well to interact. The Argo tool itself just has a few nice touches around it that are Argo specific, but you could use your existing Kubernetes toolchain if you needed to. So now I'm going to, there's a list, you can see what can happen. I'm now going to submit the same DAG to the cluster, but this time I'm not going to watch it. I'm going to open it up in the web UI. So I've submitted the DAG, and here you can see the DAG running and updating in real time. There's the sort of diamond shape that I was talking about, and that's the completed DAG. You can sort of click on the different tasks, and you can see the parameters that were passed to it, and you can also see the log output. So there, the message value was A, as we defined in the YAML. Same thing for B. And D is showing the message value is D. Now that's a simple single log message. It could be heaps and heaps of logs from your Python program or your Spark application or whatever. You can also inspect the YAML. So there's the actual YAML of the workflow in the tool. Okay, so that was the first demo. Depending on how much time we have, is there time for one more? There's time for one more. So now I'll show you another demo. It'll go through similar steps. This time it's coin flip. This DAG is doing a bit more of the conditional logic, and you can see how it can branch. So again, at the top, it's a custom resource definition of kind workflow. It's called DAG diamond, coin flip. Our entry point is diamond this time. And you've got similar tasks, A, B, C, D, that are all using the coin flip template. Now, if we dive into the coin flip, you can see that it actually itself is made up of steps. So each node, each task in the Argo DAG can actually reference another workflow. So you can have workflows within workflows. So this coin flip one is having conditional steps run. So when the coin flip output is heads, it will run the heads template. And if the coin flip output is tails, it will recursively run coin flip. So this sort of gives you conditional termination of your DAG. And you'll see that they reference the flip coin container, and flip coin container is running Python. And this doesn't, you don't need to put your code in your YAML file. This is purely for demonstration purposes. It's got a convenient HereDoc style approach where you can inline your code, but you could equally build your own Docker containers and publish them to Docker Hub or your container registry of choice, and reference them there, as we have referenced the Python Alpine 3.6. So that little snippet of code, as you can probably imagine, is randomly going to return heads or tails. And the head container, so remember there were two containers in play here. There were the flipcoin container and the heads container, which would terminate the computation. This one is just a simple echo, it was heads. It's going to run, it's just running on Alpine, and it'll, it'll return heads. So this will become a lot easier to see when it's actually run. So when tails, it'll run coin flip, else it will run echo heads. Or it was heads, rather. Just speed this along a bit. All right, finally, okay. So we're going to submit the DAG and watch it on the command line. So there we go. Task A is executing flip coin. It didn't evaluate heads, it evaluated tails, so it's evaluating flip coin again. We finally hit a heads. Now B and C are doing the same thing. They're flipping coins, waiting for heads. Looks like C hit heads. B is still going, trying to find heads. There it goes, finds heads. And finally the D, the bottom of the diamond, D's evaluating now. Didn't find heads. There, it looks like it found heads and finished. So that's a bit tricky to understand what's going on from the command line. So submitted it again to the cluster, and this time we'll follow it in the UI. So let's follow it in the UI. So there you go, flipping coins. Flipping coins. Looks like A is completed, B and C are running now. B and C are running flip coin. You can sort of see it's dynamically building the DAG. I think finally D's running. D's flipping coins, and it looks like it hit heads. So that sort of gives you a little bit of a taste of what you can do in Argo. You can see the logs for heads. And I'm about to run out of time. So if there's any questions, I can probably take a few now. Otherwise, I'll see you in the office hours.